All right, let's say we want to maximize a linear function on two variables, f of x, y is just equal to x plus y, just add the coordinates. And we want to make sure that it's constrained by these linear inequalities, that x and y are both non-negative, and that 3x plus 2y is less than or equal to 8, and x minus y is less than or equal to 1. So the first thing we probably want to do is just take a look at what that region looks like maybe, and that's something like this. So the way I graphed this was I just layered the various inequality, 3x plus 2y less than or equal to 8, x and y both greater than or equal to 0, minus y plus x less than or equal to 1, that gives me this. And what we note is that if I take, like right now, 1, 1, the output of my linear function was 2. Remember, the thing we're trying to maximize is x plus y, right? So if I go to like 1, 2 or thereabouts, I should get outputs that are close to 3, right? If I go out to this corner here, I should get outputs close to 3 as well. I should get outputs close to 2 here. The point is that as long as I stay within this bounded region, where I'm allowed to be, I'm looking for the point that will give me the biggest value. And there's clearly infinitely many points, and so testing one at a time is not actually like a good strategy, and especially if, for example, my functional turns out to be more complicated than just x plus y. So the thing to note is that for every possible output of x plus y, let's go back to x plus y equals, well, as close to 2 as I can get it. X plus y equals 2 is a line, right? It's the same thing as y is equal to minus x plus 2. And so for every possible output, 2, 3, 4, 1.7, a million, there's a line that goes with it. So let's take a look at this. X plus y is equal to c. And I don't know what c is. But c, for any value that c could have, that comes with a line. And everything in my region that goes across this line C, that's a valid solution, which would give me C as an output. So this question basically boils down to how big can I make C and still be allowed to be inside this red region. And so I can be as small as 0, right? And then I can be as big as 4. 4 really is the biggest that C could be, because after 4, I'm outside of my region, right? And so I'm going to go ahead and draw that dotted line back in. Let's put these points back. And let me just animate for a bit while I talk. So the point is that whenever I do one of these problems, I get a bunch of lines, and half of the lines coming together to form some sort of polygon. And what I'm basically looking for is some sort of value C to push a line out as far as it can go, or as far in as I can go. And so I don't need to check every single point inside this region, because any point in this region I can push it out one way or the other. I only need to check the points on the boundary of the region, and not just the boundary. I can simplify it so far as to say I just need to check the corners of this point. So when I look at this region, it has 1, 2, 3, 4 corners. I don't need to check all infinitely many points. I only need to check the 4 corner points, and then we can see that 0, 4, giving me an output of 4, is my optimal solution. Alright, thank you very much. Please let me know, as usual, if you have any questions. Thank you.